In this example, we're going to use Newton's method to approximate the square root of 5 to a ridiculous amount of accuracy to it. And so what I need is, here's Newton's method. Okay, here's my formula for it. And I need to kind of create some sort of an equation, and then I need to do the slope of that equation and kind of work that through. So I'm going to start by saying that x is going to equal the square root of 5. We're going to back it up to make this a little cleaner and square both sides. So we're looking at x squared needs to equal 5. And then we're going to go one more step of bumping the 5 over, because what Newton's method does is it finds solutions for us, solutions to problems that are not clean, right? And so we're looking for this basically. So we're looking for when it's equal to 0. So that is my equation, is x squared minus 5, is I'm basically taking this and looking for the solutions to this, which the solution is going to be plus or minus square root of 5, but I'm just going to focus on the plus square root of 5, right? And so then I'm going to do my derivative for this, which is 2x. So I need an equation that I'm finding an x-intercept for, because that's what Newton's method does. And then I'm going to apply this formula. But on applying the formula, I need to start with something. So I know that the square root of 5 is about 2 point a bunch of stuff. So that gives me some sort of a nice value to start with. And so I'm going to work through a couple different iterations. We're going to let the calculator help our cause. And I'm going to apply this formula. So we're going to do a calculator for this. So first thing we're going to do is let's store 2, right? So to store, that store button is right here. We're going to store it as x. So that's going to be, because we're going to build this formula into this calculator, and we got to have a value to plug in. So next thing is I'm going to clear out whatever equations I have. And my first equation, I'm going to write the original of x squared minus 5. My second equation, I'm going to write the slope equation, the derivative. Right? And then I'm going to basically plug in this formula into the calculator. The formula is our x value minus this fraction of our y value. And our y value we put in as, if I go to F4, y1 at that x value, because I want the y value at whatever this particular x is, divided by the slope at that y value. So I'm going to do the exact same thing. My slope equation was here, x, and I'm going to let it do its thing. And so my first iteration is square root of 5 is approximately 2.25. And then we're going to run it again and again and again, and it's just going to get more and more accurate. And so next one is we're going to store that value, right? So it saved that last answer. So it's going to store that answer as x, and then we are going to run Newton's method again. So we're starting to get closer and closer each time we do this. 3, 6, 1, 2, 3, 4, 5, 6. And then we'll store that one. Oops. Got stored as something. Store it as x. And then we are going to run Newton's method again. So our third iteration is 2.236067978. And we'll do a fourth iteration. And we'll keep doing this until those decimals don't change. And so we'll store that as x, run Newton's method. We get a 2.236067977. So everything except for that last one. So I bet if I do it one more time, I bet we're not going to get a change on it. So store it, let it run, and so we did. So that is, at least with all the decimals that we have, as accurate as we can get. And then we can test it. Matched perfectly. All right, so that was approximating some sort of a radical, a square root of some value, using Newton's method by creating an equation, starting value, and then just running Newton's method over and over again until we get approximation where all the decimals don't change.